Hello students, today we are going to discuss about that thermodynamics process. In thermodynamic process there are four type of processes there. One is the isothermal process and second one is the adiabatic process and third one is isobaric process and fourth one is isochoric process. In this class we are going to discuss about that isothermal process. Okay. We are already discussed that ideal gas equation. So that ideal gas equation, what is that equation ma? PV is equal to mu R3. This is called as an ideal gas equation. Okay. And from this equation, we are already discussed one law, that is Boyle's law. What is Boyle's law? Boyle's law, PV is equal to constant or P is inversely proportional to volume at constant temperature. The temperature is at constant. Okay. So from Boyle's law, we are going to discuss about that isothermal process. Okay. So consider one piston. Consider one piston. Then piston is bottom is thermally contact. Okay, thermally contact means when you are giving some amount of heat energy, it will be receiving heat energy and contact to piston. Okay, or suppose that piston will be generating heat energy, it will be leaving from that piston and given to that environment. So this is called as a thermally contact. Okay, so this piston is bottom is thermally contact. Okay, so here the temperature is constant. Here temperature is constant. Sir, how is temperature is constant? Now you can giving some amount of heat energy. Okay, some amount of heat energy. What happened? The volume. So this is the volume V and the pressure is P. Okay. Now the initial pressure is V1 and the initial volume is Pi and Vi. Now you can giving some amount of heat energy. What happened? The piston will be goes up. Okay, the piston will be goes up. So that temperature is constant because that when you increase when you giving that some because this is the thermally contact. The temperature is the thermal contact is connect with the environment and the piston. Okay, so that will be maybe equilibrium. So both are in equilibrium. When you increase the temperature, of the piston, so what will be happening means the pressure will be increasing. Okay, so pressure increases means volume will be increasing. So that pressure will be increases. What happen means the volume will be increasing some height. Okay, and what happen means the pressure will be decreases. Okay, so you can giving some amount of heat energy. That heat energy is constant. The pressure will be increases. Not that pressure increases, the volume will be increases. So volume increases means pressure will be decreases. Okay, so here the pressure Pi2, pressure increases from Pi to Pf. That means pressure changes from initial pressure Pi to Pf and volume changes from Vi to Vf, but temperature is constant. This is called as an isothermal process. Okay, in isothermal process means the temperature is constant, only the pressure and volume alone variable. Okay, so this process is known as the isothermal process. Do you understand, ma'am? I repeat, isothermal process means pressure, volume both are variable and temperature only is a constant. That is called as an isothermal process. Okay, now next I am going to compress that piston. This will be expand. Okay. Now I am going to compress the piston. So this is the initial volume VI, and compressed means downward. You can giving that some amount of work done it downward, so it will be comes to this point. So this is the VF final point, and the initial pressure PI and final pressure PF. Okay, PF. Now the temperature here, that bottom is thermally contact. When you reduce the volume, the pressure will be increases. When you reduce the volume, pressure is increases. Pressure increases mean temperature is also increases. But here it is a thermally contact. So thermal contact means when the temperature increases means the temperature coming out to the piston. Okay, so here the thermal temperature, here environment, what is the temperature? At the same temperature only will be there. Okay, so here the temperature is constant, pressure and volume are variable. So this process is known as the isothermal process. Okay, we understand, ma? So PV, what is the ideal gas equation? PV is equal to mu RT. Okay, so mu is the number of moles and R is the ideal gas constant and T is the temperature. So PV is equal to mu RT. So this mu is constant and R is also a constant. So in isothermal process, T is also a constant. So we can write this PV is equal to constant. Okay, PV is equal to constant. Then P is inversely proportional to volume. When you increase that volume, pressure will be decreases. When you decrease the volume, the pressure will be increases. So P is inversely proportional to volume. Okay, do you understand, ma? Now we are going to draw a graph. Okay, now we are going to draw one graph. So in x-axis you can take that volume and y-axis you can take that pressure. Okay, when you increase that volume, initially the pressure will be there. So this is the PI, this point. Okay, so when you increase that pressure volume, the pressure will be coming down. Okay, pressure will be decreasing. So this like this. Okay, so this will gives that parabola. Okay, so this graph shows that this is the parabola. So this will be a temperature. Here the temperature T is constant. Okay, now that piston will be, you are going to compress it, expand. Okay, isothermal expansion. The piston will be expand like this. So this point you can expand. So from this is the VI and this is the VF. So here this point you can see that VI and the pressure PI. PI and VI. Okay, and this is the final point. So this point is called PF and VF. So this graph shows that isothermal expansion. When you increase that volume, the pressure will be decreases. So this will be like a parabola. Okay. Now suppose if you take that isothermal compression. Isothermal compression means you can compress that piston. Okay. So this is the initial piston VI and you can compress it at the final point is VF. So this is the VI and this will be VF. Now you can, this is the volume, you can increase that volume, reduce that volume. Okay, so you can reduce that volume. What happened? The pressure will be gradually increases. So this graph also shows that this is also shows that parabola. Okay, do you understand, ma? So this is called as an isothermal process. Okay, then next work done in an isothermal process. Work done. Here you can compress the piston or expand the piston. Okay, you are doing some work done. So how much work done will be needed? So that work done we are going to calculate. Okay, so how to calculate? So first of all, work done is equal to, what is the formula? PdV. Work done is equal to P dV. So now you can integrate this equation. Integral of dW is equal to integral of P dV. Okay, so you can get W is equal to integral of P dV. That volume will be changing from initial volume VI2 and final volume VF. Okay, work done is equal to, this is the formula for work done, VI to VF, integral of VI to VF and P dV. Now, we are going to calculate that pressure. So, how much pressure will be there in that piston. Okay, so how to calculate? By using that ideal case equation, PV is equal to mu RT. Okay, PV is equal to mu RT, then P is equal to mu RT divided by V. Okay, from this equation we can get P is equal to mu RT divided by V. So this is the equation number 1 and this is the equation number 2. You can substitute 2 in 1. Second, you can substitute the equation number 1. So W is equal to integral of VI to VF P. Okay, so P you can replace by mu RT by V. Mu RT divided by V into dV. Okay, then mu RT is a constant, so you can take them out of that integral. So W is equal to mu RT integral of VI to VF dV by V. So here remaining term dV by V. Integral of dV by V is called as a log of the formula is log of V. So here natural log of V, LNV. Okay, so when in denominator, if you differentiate the denominator, you can get that numerator, so you can substitute that log of, okay, log of denominator. So this is the natural logarithm of V. In science you are using that natural logarithm. So Ln, this Ln represents that natural logarithm of V. Okay, so you can substitute that. Then W is equal to natural logarithm of W is equal to mu RT of natural logarithm of V from initial volume VI to final volume VF. Okay, then work done is equal to mu RT. First of all, you can substitute that upper limit and minus lower limit. So Ln VF minus Vi. So you can get W is equal to mu RT of Ln logarithm of VF minus Ln Vi. So Ln VF minus Ln Vi, that is natural logarithm of final volume minus natural logarithm of initial volume. Log of A minus log of B. What is the formula? Log of A divided by B. Okay, so this formula you can substitute. Then W is equal to mu RT of natural logarithm of VF divided by Vi. Okay, so this is the work done in an isothermal process. The work done in an isothermal process, what is the formula? Mu RT natural logarithm of VF divided by Vi. Here VF by Vi is greater than 1. That means final volume is increasing. Okay, final volume is greater than initial volume. So this process called as an isothermal expansion. Okay, expansion only, that volume will be increasing. Okay, so the final volume is maximum and initial volume is final volume is greater than that of initial volume. So VF is greater than Vi. So VF divided by Vi is greater than 1. Okay, so V greater than 1 means What about that natural logarithm value? Natural log of 1 value is 0. Okay, so greater than 1 value is natural logarithm of Vf divided by Vi is greater than 0. Okay, greater than 0 means that is positive. So work done is positive. Okay, in isothermal expansion, isothermal process where that isothermal expansion, the work done is positive. Suppose that a final volume is less than initial volume, that is isothermal compression. Okay, the final volume is final volume is less than initial volume, so less than 1. Okay, Vf divided by Vi is less than 1. If less than 1 means that value, what is that? Logarithm of Vf by Vi is also less than 1. Okay, so is also less than 1. Do you understand, ma? Okay, less than 1 now, what happened? Less than 0. Less than 0 means what is that value? This is a negative. In isothermal compression, the work done is negative. In isothermal expansion, work done is positive. The isothermal compression, work done is negative. Okay, ma'am? Okay, do you understand? Okay, ma'am. Okay, thank you.